I want to find the particular solution of this derivative, and it's going through 1, 3, and we're going to focus on the right side. You can basically ignore this for now for what we're doing, but we're focusing on the right side, the positive side of the x-axis. So the first step would be to first change this to be dy equals negative 1 x to the negative second dx. Then I'm changing it to a differential. Then I integrate both sides. The derivative of dy is simply y. Sorry, the integral of dy is y. The integral of this, well, you add a power, so that'd be negative 1, and you divide by negative 1. And don't forget plus c. So we now have y equals, the negatives cancel, leaving you 1 over x plus c. That's your general solution. When I plug in 1, 3, this is x, this is y. So y is 3, x is 1. That means that c looks like it's going to be, that's 1 minus it over 2. Since c is 2, my answer is y equals 1 over x plus 2. That would be my particular solution that goes through this coordinate. Number 62. I want the particular solution that starts with the second derivative and works its way down to the regular function. So you're doing it twice. So to work your way down, the first thing is, if I integrate both sides, I basically will get f prime x is equal to the integral of sine is negative cosine. Is that correct? Is the integral of sine negative cosine? Yeah. Plus c. Now plug in 0, 1. Cosine 0 is 1, which c ends up being what? 2. Thank you. So the derivative of x is going to be negative cosine x plus 2. To find the original function, when we integrate this, we get f of x. The integral of cosine is sine, correct? So this would be negative sine x plus 2x plus c. That's right? Hopefully? Yeah. Now we plug in 0, 6. So 6 equals negative sine 0 plus 2 times 0 plus c. Sine 0 is 0. That's 0. So c equals 6. So my answer is the original function would be negative sine x plus 2x plus 6, the c value. That would be my original function, starting with the second derivative of sine x and having these two pieces along the way of information.